Today, we are going to be talking about how machine learning is being applied in cybersecurity. We will also be discussing how data science can be used to improve threat analysis and threat detection.
All right, Jaime, so based on this discussion that we already had, maybe you can take us into a little deeper on how you are working with data science and machine learning in the area of threat detection and threat analysis.
Absolutely. So one of the things that I want to start with is clarifying a little bit some misconceptions on whether, in the cybersecurity industry, you're seeing many players talking about using AI and machine learning. So this is something that, those two words, you're going to see people using them pretty much in the same context, but I wanted to clarify a little bit what that means. For me, artificial intelligence is more the broad field. And, within artificial intelligence, we can talk about general artificial intelligence and narrow artificial intelligence. So general artificial intelligence is something that doesn't exist yet, right? We haven't been able to create an artificial intelligence that is able to generalize and reason as well as or better than humans. So when we talk about narrow AI, that's what machine learning is models that are able to solve a particular really well-defined problem.
Right now, we have a very narrow definition of functional artificial intelligence, and machine learning is one version of that, one technique that might be used to teach a machine how to solve a problem.
You know what, I think just a quick comment here, I think what the next stage that we need to get to is using artificial intelligence to figure out how to apply artificial intelligence. I mean, quite frankly, that's where it has to be. And it's going to continue to be iterative like that to get deeper and deeper. So
I totally agree. And if you see some of the latest research from DeepMind, Google, and others, the field of auto ML, it's really, there's a lot of investments there. And for those of you that don't know what auto ML is, as Brian said, it's basically training a neural network to come up with new, neural networks that you can apply.
That will be the path to singularity, in my opinion.
So, we can divide machine learning techniques mainly in two categories, and actually we'll argue three, but let's keep it with, supervised machine learning and unsupervised machine learning. And then that third one that we are not going to talk about today because I still haven't seen many use cases within cybersecurity is reinforcement learning. But let's focus on supervised and unsupervised methods. We talk about unsupervised machine learning in the area of anomaly detection or data exploration. And a point that I wanted to make there is we have many cybersecurity products out there that are applying unsupervised learning, and that includes clustering, anomaly detection, etc. I'm not a huge fan of those algorithms in the cybersecurity context because they are prone to many false positives.
Things that are just clustering and finding things that are similar won't necessarily find you something malicious. That's when you need to apply a model that has trained data where someone else has already gone through and done the work and then shows the model, this is what you're looking for.
The most successful problems for machine learning models are going to be those where you have access to a very high-quality data sets that have been trained and labeled, and where you can apply a supervised learning model that can make predictions about that data set that you have trained on.
To me that raises an interesting question because I'm thinking about you guys have done the work on your side to train it for your particular data sets. I mean, the existence of a really good training data set kind of implies the existence of an expert in that data set already. Mm-hmm. So someone has had to take a look at it and categorize it and tag it up. Do you find that categorizing and tagging up a data set from, say, one organization gives you a good view into, if you were to use that exact same model in a different organization, like take two, Fortune 500 companies with very different networks and very different structures and activities, do you find that they actually do, the model from one applies well, or is there extra training that has to occur before it becomes useful?
So I will say it highly depends on the use case, right? And when thinking about that problem, one of the approaches that some companies are taking is using their customers to train those data sets. So we were talking about how not many people are really qualified to train these models, right? So, like, trust me, like many customers out there are going to be making bad decisions, and in the end, you're going to end up with a model that is trained with data that is noisy or labels that are not correct, and in the end, that's going to be even worse. So yeah, I mean, you really need to make sure that the quality of your training data is extremely good. Otherwise, it's going to be hard.
Yeah, I think this kind of feeds into that concept of talent amplification that we talked about a little bit earlier.
Okay.
That is, how does the data get labeled? The talent that knows how to find the relevant things labels it. And I think there's the notion of active labeling. That is, you don't have to have a historical necessarily data set that is labeled. You can have your current data set being labeled by folks that are doing analysis and providing a feedback mechanism into the machine learning so that future events that look like that will be flagged as potential security events.
Okay.
And then it's an iterative process, that is to have the talent continuing to feedback into the machine learning so it starts to learn what the talent recognizes as being relevant. There are tools that can be used to solve problems, but it requires technical skills to apply those tools and solve those problems today. It's not as if you can just stick somebody in front of it and they figure out how to solve the problem.
So I wanted to share with you one particular example of how we are using machine learning today at AT&T Cybersecurity. So one of the processes that we run is we collect a huge amount of malware samples per day, and basically we have a system that automatically collect those samples, perform a static analysis. That is, what do we know about the file? What can we learn from the file without actively executing that file? And then we have a second system that is doing what we call dynamic analysis. That is, executing the malware sample in a sandbox, and then analyzing what happens when you execute that sample. So as you can imagine, that's a huge amount of data, right? We are talking about, right now we are doing pretty much 200,000 samples per day. And, we are storing all that information. And, thanks to that, we are applying machine learning in a couple of places there. One of them is actually using unsupervised learning to cluster malware families. So to give you an example, if I had to give my team the analysis of 200,000 samples every single day, and they had to go and manually verify whether that's a new malware family, that will be, I will really need 1,000 threat analysts. What happens is we are actively using some unsupervised techniques to basically generate clusters out of that activity. So in the end, at the end of the day, what I give my team is a set of let's say 10 clusters of malware samples that exhibit a similar behavior, right? As Brian was describing, a human will have a really hard time doing this because it's high dimensional data. You're talking about, thousands of different features that you have to look at. And a machine is really good at making, establishing those relationships. And this particular technique is saving us a lot of time.
Mm-hmm. And from that, you would get consistency from the machines. That is, if you have an analyst doing it, they're going to probably weight things differently. And, this kind of looks like this, but maybe there are other attributes that are hidden that are really kind of like that. At least you'll get consistency in how they get clustered over time.
Absolutely, and that's actually good, as you said. You need some consistency there, especially when you are looking at writing signatures out of those behaviors. Mm-hmm. So the second example I wanted to share with you is actually using the same data set. A problem that we are looking at right now is, since executing those malware samples in a sandbox is actually costly, in terms of resources and in terms of time, because you may want to leave those samples executing there for a few minutes, or sometimes even more than that. So you have to have enough computer resources to do so. So one of the things that we are looking at is, can we predict what the behavior of the malware sample is going to be when executed in that sandbox, actually without executing it? So we can skip that step in some of those malware samples. So as you can imagine, we can use that data set that we have of all the static features that we extract and previous dynamic analysis to see what happens when we execute the sample. So in the end, we can create a model that can say, based on previous observations, the probability of this sample connecting to the internet is 90%. Or based on the static features, the probability of this sample actually exploiting a particular vulnerability in the endpoint is going to be X. So that way, it's actually letting us use those resources in a smarter way, because we can skip many of those analyses that are not going to be driving some of those malicious behaviors that we are looking for.
Mm-hmm. So that in that case, you're predicting the behavior of something you have in hand. It's not as if you're trying to predict the future. Right.
Yeah, exactly.
Yeah, very good. And those are very good applications of machine learning technology that really demonstrated a lot of the topics we discussed earlier in terms of talent amplification, scalability, consistency or accuracy in the analysis. Very good.
Cool. I feel like we're on the right track, and that's a comforting thought, that we understand that there are limitations to what can be solved with it, but we're also applying it in interesting and unique ways that hopefully will pay off.